Welcome! We mentioned in the previous lecture that our dependent variable for the PD model will be an indicator of whether a borrower defaulted or not. We are going to create this indicator based on a default definition, also known as a good-bad definition. What data do we have in our dataset about borrower performance and repayment behavior? It seems that the only piece of relative information we have is contained in the loan status column. Let's display its unique values. Here they are. So each loan has one of these statuses: fully paid, charged off, current, default, late 31 to 120 days, in grace period, late 16 to 30 days, does not meet the credit policy status fully paid, does not meet the credit policy status charged off or issued. Evidently, accounts that have been fully paid have not defaulted. They're good. Same applies to current issues or accounts in the grace period. On the other hand, charged-off accounts have definitely defaulted. Therefore, they are bad. Same goes for accounts with status default. Let's use the value counts method to see how many accounts there are for each status. Great! It is useful to see the proportion of accounts by status. We can get it by dividing the expression we just used by the total number of the accounts. We'll do that using the count method. Awesome! Now it's time we develop a more precise default definition. We'll store our good or bad flag or non-default default indicator in a new variable called good_bad. Like any other indicator or dummy variable we have seen so far, this too will contain only zeros and ones. We could choose freely which of these values would indicate default and which non-default. Here's how the logistic regression would work. First, we will assess the relationship between the dependent variable and the independent variables. Second, we'll estimate regression coefficients of each of the independent variables. We mentioned we want an easy-to-interpret model. One example of easy of use is that we prefer positive coefficients to indicate positive quality, that is, higher credit worthiness, so positive means good or better. In the same way, we'd rather negative to imply bad or worse. How is this technically achieved? Well, whatever we assign the larger value or the 1 to will be shown to increase with the increase of the respective independent variables by the positive coefficients. For instance, we can set 1 to represent default and 0 to represent non-default. So we ran a regression model and got a positive coefficient for debt-to-income ratio. Therefore, the probability of default increases with debt-to-income ratio. Since in real life we associate positive with a positive feeling, we prefer that a positive coefficient would signify a better state, a better quality of the account. In this example, the case is exactly the opposite and is a cause for confusion. Hence, in our good-bad variable, we'll use the value of 1 to represent good or non-default accounts, and we'll use the value of 0 to represent bad or defaulted accounts. Technically, this translates to assigning 0 to all loans we indicated as defaulted at the beginning of the lecture. We'll assign 1 to all other loans. To do this, we'll use the NumPy function, np_where. It works very much like the if function in Microsoft Excel. It checks if a condition is true and assigns the respective values. In this case, we'll check if the status of the loan from the loan_status column is one of the statuses we consider representing default. Let's use the isIn method. This method checks whether a value is in a list of values. That's right, we need to have a list next. That is, here we'll have to list all statuses that we define as default. They are charged off, default, does not meet the credit policy status charged off, and late, 31 to 120 days. Next, the np_where needs 2 more arguments. First, what value will be returned if the condition is true, and second, what value will be returned if the condition is false. As we noted, if the condition is true, that is, if the loan has a status previously defined as default, we want the function to return the value of 0. Naturally, if the condition is false, that is, if the loan does not have a status previously defined as default, we want the function to return the value of 1. Let's execute the code and display the good-bad variable to see what we achieved. Great! We have successfully applied our default definition. We have our good, bad, or non-default default indicator, which we can now use as a dependent variable for our probability of default model. In the next lecture, we will look into the independent variables. Thanks for watching.